What's up, Algebra 1? It's me, Mr. Gerber. I know that you missed this ugly mug so much. Yes, I am a little bit sunburned. I hope that you're getting outside during this quarantine. But this week, we're still learning and coming back to things that we've already done a little bit, okay? This video right here is all going to be about arithmetic and geometric sequences, which is where we left off. So let's get started with the video. Transition.
All right, everybody, let's talk about arithmetic sequences. So an arithmetic sequence is a sequence where the difference between one term and the next is a constant. And primarily they use the letter D to stand for difference here. So, as we remember before we left for break, an arithmetic sequence can be used when we are adding or subtracting by a constant term, or in this case, difference. So, a common difference in, let's say, our example right here, 1, 2, 3, 4, we are looking to see how can I go from 1 to 2, 2 to 3, 3 to 4. Well, in this case, D would be positive 1, or by adding by 1. Now it comes to that second half of not only recognizing that it's an arithmetic sequence, but we have to write an equation for it now. So we're going to need three things. First thing that we will need is our first term, which in this case for our previous example was 1. Then we will need a common difference, so D. And we figured out that D was adding by 1. And then we will need a term, number, or whatever we are trying to solve for, okay? So we can see each of these elements being used here. We have our first term, we have our common difference, maybe, there we go. We have our common difference, and we have our term number right over here. And it's going to be our term number subtracted by 1. So let's put this into practice. This first example is actually something that I copy and pasted directly from Khan Academy. So this is something that you should have seen or something like this. So if we remember everything that we need in order to write an explicit formula for an arithmetic sequence, we need our first term, our difference, and our term number, in this case n. This is automatically telling me that my first term, which is indicated right there, is equal to 8. So I know that 8 is going to be in my equation or in my explicit formula. Now this second part, this second equation I know can be pretty confusing because it's not something that we have typically worked with. When they give you something like this, the one spot that you need to look at is right here. This is telling you what the difference is. That is D. So in this case, this common difference is being subtracted by 13 every single time. So I know that I'm going to need to have minus 13 times n minus 1. And pardon the bad handwriting, I'm trying to use my fingers on my iPad and things can get a little messy. But this is my first equation right here. C of n is equal to 8 minus 13 times the quantity n minus 1. Let's try this for another example where it's not broken down like this. We're going to try this for example 2. Write an explicit formula for our sequence of -5, -1, 3, and 7. Well, the first thing that we need to identify is what our first term is. In this case, that's going to be -5. I need to find out what my common difference is now. How can I go from -5 to -1, -1 to 3, 3 to 7? In this case, I think that we could all figure out that this is just adding by 4 every single time. So let's write our explicit formula. So I need a of n or x of n, whatever letter you want instead of a. That's just saying this is the function or the sequence a. So I need my first term of a, adding by my common difference, n minus 1. And that is my explicit formula for this example. Nothing too out of the ordinary. It's a lot of finding individual pieces and putting them into the formula. And this is going to be the same thing for geometric sequences. A geometric sequence is a sequence where each term is found by multiplying the previous term by a constant. that constant is actually going to be considered as R, an R which is also known as the common ratio. So we can write explicit formulas for geometric sequences kind of like this. This is our sequence down here. It's our first term, which we can see is still A. And then we need to make sure that we have our common ratio in there. So our common ratio, then it's A times our common ratio. And then we need to look for our term number, or in this case, it can be seen up in the corner there. So if I wanted to rewrite this so that way it was an explicit formula just for us to see, I'd have A of n equals my first term times r to the n minus 1 power. Now let's put this into action. Write an explicit formula for 1/2 to 8. Well, in this case, I already know what my first term is. My first term, or A, is 1/2. So I know I'm going to need that in my formula somewhere. I need to figure out what my common ratio is. A lot of times you can do this by taking the second term number and dividing it by the first. Or in this case, 2 divided by 1/2, or 8 divided by 2. I think we would all find and recognize that in this case we're increasing, which means I'm multiplying, and I'm multiplying by 4. So I know that my r is 4. And now I just need to include my n minus 1 as my exponent, and that's it. That's my explicit formula for this sequence. Let's try it for one more example. They want to know, given this geometric sequence formula that they already have given me, what is the fourth term of this sequence? So that means that my n is 4. And really what we do, essentially in all of mathematics, whenever we are given something that we know, we need to make sure that we can substitute those pieces into equations or formulas or pieces that we're working with. So I need to put this 4 wherever I see an n. So let's rewrite this. So this is the fourth term of the sequence b is equal to 1 times negative 2 to the 4 minus 1, which is essentially negative 2 to the third power, which is like negative 2 times negative 2 times negative 2. I have an odd amount of negatives, which means my answer is going to be negative. And 2 times 2 times 2 is 8. So negative 8. So the fourth term of the sequence b is equal to negative 8. Let's do a nice little wrap up. Summary of what we just talked about. The explicit formula for an arithmetic sequence and the explicit formula for a geometric sequence. For both of them, we need to know what the first term is. In this case, that is going to be A. And where things get a little different, for an arithmetic sequence, which we know can be found when we are adding or subtracting by a constant number, or a constant, that's going to be represented as D. For a geometric sequence, it's whenever we are multiplying or dividing by a constant, and that's going to be R. And you can notice here how both of these still have n minus 1 somewhere in their formula.